This is Jason On,
and Leslie Kim.
and today we will be showing you the basics of data curing with FEFI and FHDI.
The resources for this course and presentation was provided by Dr. Cho, PhD.
So here are the following topics that we would cover throughout the video. First, we'd be talking about the problem or the missing data, and then we'd be talking about the solutions or data curing. With that, we'd be talking about the R package, which is the software that we would use to proceed with the data curing process. And finally, we'd be giving you some explanations of how to use the FHDI and FEFI. So the first step of data curing is correctly identifying the problem. Let's say you broke your car and went to the mechanics, or you got injured and went to the doctors. The first thing that they would do is that they would identify your problem and examine the cause and symptoms of your problem or pain or malfunctions. By doing so, they would be able to assign you with the appropriate treatments that could resolve your problem. And that's the same case for data curing. The purpose of data curing is to accurately substitute the missing data with appropriate values. Thus, identifying the missing data is a crucial step of data curing. So there are many factors that could contribute to missing data. They could be human factors or hardware problems such as sensor connections or internet problems. And they could also be data inconsistency and many more, since missing data is persistent in every scientific and engineering fields.
And here's an example of missing data. As you can see, there are blank spots in the data table that are missing crucial information, and that makes it difficult to perform calculations to analyze the data and makes it pretty unusable to create a well-trained algorithm. Like Jason was saying before, there are a lot of ways data can get messed up. For example, if you were running an experiment on the water quality of a dirty lake and your hardware went wrong and only collected water samples on Mondays, when analyzing your data, you might come to the conclusion that the dirty lake is only dirty on Mondays, and the rest of the days you have missing values that show it has good water quality. So when hardware goes wrong, this can lead to incomplete data in your experiment that can cause improper conclusions.
Now, after identifying the missing data, our next step is to actually cure them. And there are a lot of ways of how to recover the missing data, but we will talk about the 4 most used techniques. The first technique is naive remedy. Naive remedy could be done in 2 big ways, which one approach being deleting and the other approach being guessing. Now, deleting is basically removing all the rows with incomplete data. And due to its simplicity, it has a lot of issues, such as reducing the quantity of the data, showing biased results, and it also has low accuracy in predictions and learning. Now, the other approach is guessing, which is basically entering missing values with intuitive guesses, such as mean, median, or random values. So it is also very not accurate due to its biased results. Now, overall, naive remedy is a relatively simple approach in data curing, but consequently, it is not very accurate due to its simplicity. So here is an example of how inaccurate the naive remedy could be. This graph is a RMSE graph, which RMSE stands for root mean square error, and it is a standard way to measure the error of a model in predicting quantitative data. So basically saying that the higher level of RMSE it has, it implies that it may have more errors and it is less reliable. And the lower the RMSE, it indicates that it is a better fit and it has less error, so it's more reliable. Now in this graph, as you can see, the green values are the naive remedy approaches, and they have a significant level of RMSE, which implies that they may have a lot of errors and that they're less reliable. And contrastly, the blue values, which are the FHDI approaches, the FHDI has a significantly lower value of RMSE, which implies that they may be more reliable and they perform much better than naive imputations on a machine. So there are more techniques other than naive remedy, and it is called imputations. And imputations could be divided into 3 big categories, which are multiple imputation, hot deck imputation, and fractional imputation. And Leslie will talk about this in more detail.
Let's first talk about multiple imputation. This is where you replace missing data by creating a bunch of possible imputated datasets and estimating the value by combining all those possible results. While popular, the trade-offs are that it requires an understanding of the data to be effective and requires a lot of time and computing power because it's generating so many possible cell values. Another method is hot deck imputation, and this is a method where missing data is replaced with the same value that most closely corresponds to. For example, if there was a height to age dataset and one row of data showed that a kid that is 8.5 years old is 4 feet, if we applied hot deck imputation for an 8-year-old that is just barely older than 8.5, we would fill that missing height column as 4 feet because those two values are so similar. This can lead to less bias as we aren't creating our own computer-generated values and instead are relying on those that already exist in our dataset. Finally, with fractional imputation, we can get more efficient and less biased results by locating possible cells that could donate their values to the missing cell. Then by applying some weight so some donors influence the final replaced values more than others. This creates variation that also prioritizes donors that may be closer to the true value and make sure that we are not biasing our data and getting more accurate results.
Now, in order to try the data cleaning process by yourself, a great tool to use is the R package. And we will walk you through of how to install the R package, and in the next video we will also be showing you of how we could utilize it in a real-life application. Now here are the resources and links of where you could download the R package and RStudio, and they would be in the description box below, so you could click on the link and it would guide you through of how you could download it and where you could download it.
So now that you have your R package, let's delve a bit deeper into how fully efficient fractional imputated FEFI estimators and fractional hot deck imputated estimator FHDI work. So, FEFI replaces missing cells with other values inside your dataset, and this doesn't actually vary our data all that much. However, FHDI replaces those missing cells with randomly selected donors, so there's variance that decreases bias. Now, the FHDI R package has some important tasks to do in order to fill missing values, and you might be wondering how it works. First, it needs to construct a cell for that missing dataset and fill it with a temporary value of 2 donors. It then looks around at the rest of the surroundings, observing the neighbors, and gathers a random number of donors. Finally, it updates the cell by weighing the random donors to come up with its final predicted cell value. Now, this process is done to your entire dataset, and just like that, you have a completed dataset with less bias than traditional methods.
Thank you so much for watching our video, and don't forget to check out our next video, which is about how we could utilize the R package and have it applied to the real-life applications.